Welcome back, and we have Josh next to me. That's right, next to me again. Josh wasn't finished talking today, so now Josh will talk to you a lot about our HashiCorp Vault Issuer, and more specifically, how to use vaults to limit who can request which certificates. Hi, Josh.
Hi, everyone. Thanks, Marta. Yeah, hi, everyone again. Indeed, getting close to 8 o'clock, so I'll try and be quick with my talk. So I'm going to talk today about Cert-manager with Vault and how we can leverage Vault's certificate policy to limit the certificates that can be signed based on the identity that has requested them. So this is kind of conjurant to what I was mentioning earlier about kind of implementing this kind of certificate policy idea, which is particularly important for your kind of internal PKI with your clusters with multi-tenants and kind of limiting bad actors and strength in depth, etc. So in this talk, I'll go through a very brief overview of how Cert-manager works and how the certificate lifestyle and the flow. I'll mention the Vault issuer and how that works, and specifically with the Kubernetes service account authentication. I'll then briefly touch on certificate roles with Vault and a little demonstration on how we can leverage this Vault issuer to manage or implement certificate policy using Vault. So a brief overview of the certificate life cycle with Cert-manager. So first of all, we have a certificate that you're probably familiar with, and this is kind of a human friendly, readable YAML file which will describe the certificate that you'd like to be signed for you. Once created, Cert-manager will then create a certificate request, which includes your X509 encoded certificate request document inside that resource that's created in the API server. Cert-manager is also watching this resource, and this will then be sent off to your configured issuer or cluster issuer, and then based upon the spec of that issuer or cluster issuer, then gets sent off to a real CA through whatever implementation that backs that. So in our case, this would be Vault, or indeed it could be your self-signed issuer, CA, Verify, etc. Once that gets signed, it then kind of goes back up the stack, and your certificate will then be stored in a secret, a Kubernetes secret, along with the private key, and then that can obviously get mounted into your pod as a kind of secret map. So next on is the Vault issuer. So there are 3 authentication methods that we support in Vault. The most important here is, of course, the service account auth that I'm going to be talking about in a moment. And this is where we can provide a Kubernetes service account that has been bound to a Vault role and use that as authentication when signing our certificate request. So in the case of the Vault issuer, we'll have our kind of Vault issuer here that will see the certificate request to get signed. That will get sent off to Vault. And in that request and behind the scenes, it's going to be using the service account JSON web token that we've referenced in that issuer spec as a header to our certificate request to Vault. Vault will then authenticate that JSON web token. It'll then it will authenticate that JSON web token based on a token review to the API server. So it's going to send it off to the API server to get some identity about the token or about the service account. And then once that's returned, it's going to map that service account identity to a Vault role, which will have some policy attached to it. In the kind of Vault policy configuration, and then all being well, that's passed its kind of internal policy check, it'll go ahead and then sign that certificate using Vault's internal private key, the signing private key that's been configured, and then send that back off to the Cert-manager issuer. So there's quite an exhaustive list of possibilities for Vault certificate policy. And there's, as you can see, quite a few on this list. The one we're going to be mostly focusing on today, if I can see it, is going to be allowed sans names. I can't see it. I can't see it somewhere. Anyway, it's on that list somewhere. But as you can see, there's quite an exhaustive list of policy rules that we can use. I'm using Terraform in this demo to configure Vault. I found that to be the easiest. And the way that we've set this up is we have defined some service accounts. So we're creating the service accounts through Terraform. In this case, we just have service A and service B. And they are going to live, or that's going to be the namespaces rather, more importantly. So we have service A namespace and service B namespaces. And then in our certificate policy here, we have mapped the service accounts that we defined here into certificate policy here. And most importantly, we have allowed domains here. And what this means is the service accounts living in service A, for example, are only allowed to request certificates, which would be routable through the kind of Kubernetes services. So you think about Kubernetes services, you know, you have your kind of service.namespace as its kind of domain. It means that we can only request certificates that are valid for our namespace. And what this means is that you can have a tenant, a multi-tenancy cluster, where you have a single tenant which might have access to an entire namespace, including secrets. But the secrets that they can request using service accounts from their namespace are only valid for just their namespace. You won't have a tenant which is able to request a certificate which is valid for another namespace and potentially, you know, cause some nastiness that way. So it's a nice way to lock down a certificate signing, but based on namespace and therefore kind of valid DNS names in your cluster, without restricting access of tenants to everything inside that namespace. So there's no need to block access to secrets, etc. It's still done on the namespace level, which is quite a powerful thing when kind of trying to enable your tenants, you know, to have as much access as possible to kind of get their job done. So in this kind of multi-tenancy cluster setup, you'll see here we have these kind of two namespaces defined here, and our two users, Alice and Bob. They'll authenticate to their own namespace, which will have some workloads running, consuming or mounting secrets, which are produced from our Cert-manager certificates. And they each have an issuer in their own namespace using a service account that's authenticating to Vault. And either when, you know, Alice or Bob create their certificates referencing this issuer, they're obviously using different service accounts in the separate namespaces, and they'll be bound to their respective roles in Vault and be matched against, you know, their own separate policy. And I'm probably running out of time, so I'll go quite quick. This is just a quick kind of demonstration on the RBAC rules for each of Alice and Bob. This is for service A, for example, so that's service A namespace. I'll get to my demo. So I have a cluster running. It's got some things running it. It's got Vault, and it's got some kind of application, or an application running in service A and service B. If I get issuers, for example, you can see that I've got this service A issuer running with Vault, and my service B issuer, or my Vault issuer running in service B rather. So let's say for a second that I'm Alice, and I want to create this this certificate. This looks fine in terms of for Alice to create. So this is in the service A namespace. You can see from the DNS names, it's creating a front end .service A certificate. So that should be fine, and that is valid for this namespace and the server. So we go ahead and create this this good cert. We should then see that if we get our certs and service A, you should find that you know, it's fine, that got signed by Vault, and that certificate is now ready to be mounted to pods, etc. But for example, if I was to create a quote-unquote bad cert, so you can see in this example, I'm still in namespace A, but I'm creating a certificate that is valid for front-end.service B, which is indeed obviously another namespace and shouldn't be allowed to be created in service A. So I'll go ahead and create this bad cert. And if we get our certificates, you can see this front-end bad cert is not ready. And if we get the certificate request from the namespace as well, you can see already there. So I can describe this front-end bad cert. And you can see it's quite nice. We get quite a nice error back from Vault. So assigning error, Vault failed to sign certificate by Vault, and it's due to a subject alternative name frontend.service-b not allowed by this role. You can see that we quite cleanly kind of lock down kind of certificates that can be requested in each namespace. That's it for this demo. Here are the resources that I used. I think this is probably the most important, the kind of demo that you can find in my GitHub. And yeah, that's it. That's all from me. I don't know if there's any questions.
Thank you, Josh. Currently, there are no questions in chat room. We're also running out of time. So I propose you just answer those in YouTube itself.
Mm-hmm.
So,
yeah, no, that makes sense.
Yep, thank you.